Okay, so back again, working through the study guide for applied math. We'll start with chapter 5 now, the exponent rules. We only do just this one section of chapter 5, 5.6, exponent rules. Only 3 questions on your study guide specifically about those, but there's all kinds of exponent rules, and so hopefully in your homework for this section you got into this a little deeper. But one of the rules says if you have like bases and you're multiplying, you can add the exponents. So 2 to the third, 2 to the second makes 2 to the 5th power. So when you multiply like bases, you add the exponents. But then actually this one asks you just to work it all the way out. So you take 2 raised to the 5th power. You can do that on your calculator. That is 32. That means 2 times 2 times 2 times 2 times 2. 2 to the 5th power, 2 multiplied by itself 5 times. But most calculators have a little up arrow caret button. You can do 2 raised to the 5th power. It will do that work for you. If you don't have that button, some calculators use an X raised to the Y button. So, but your calculator most likely has an exponent button. All right, the next rule, number 14 on the study guide, 4 to the 10th divided by 4 to the 4th. This rule is the division rule, or the quotient rule for exponents. It says if you have like bases, when you're dividing, you subtract the exponents. So 10 minus 4 would be 6. So we can say this is 4 to the 6th power. Again, the directions told us just to work that all the way out. So take 4 raised to the 6th power. I should have my calculator out. So do the 4, the caret button, 6, and that is 4,096. All right, this next rule, the negative exponent rule, says any base raised to a negative exponent can be written as 1 over that base to the positive of that exponent. In other words, moving the base down to the denominator makes it a fraction. It changes the sign of the exponent. So this is actually 1/36. Next topic is scientific notation. To write something in scientific notation, you need a number. That number has to be between 1 and 10. It can also equal 1. So greater than or equal to 1, but less than 10. So some number between 1 and 10 times a power of 10 raised to some integer exponent. All right, so for number 16, we're asked to change this out of what would be considered decimal notation, just regular notation, into scientific notation. So we need to write it so that the number n is between 1 and 10. So right now the decimal point's at the end, so we're going to move it over what would take 5 places to make it 7.96. And then we say times 10 to some power. That power is always how many places you moved your decimal point. So this may, not just how many zeros there are, but how many places you moved your decimal point, which is 5 total places. And you can check this on your calculator, 7.96 times 10 raised to the 5th. You should be able to verify that that is an equivalent value. Okay, number 17, do the opposite. It's in scientific notation and we want to take it out. So again, you can just do this on your calculator. A lot of these problems, actually, your calculator will be able to handle and work out. But I want you to also know that this means 6 decimal places. The exponents is always how many places you move the decimal point. So since it's a negative, we're moving the decimal point back over to the left. So 6 places from where the decimal started. So that would be 1, and then you're going to wind up going 5 more places, so 5 zeros in that. Number 18, we have 2 values in scientific notation multiplied together. So scientific notation already has a times sign in it, and then times another scientific notation with a times sign in it. That is just one big multiplication problem. So really, the parentheses could be dropped. It's not the FOIL method if you were thinking of the FOIL method, because those aren't plus signs, they're times signs. So it's all just multiplication. We know we can multiply out of order. Any order is okay. So I would take the 2.7 times 6, get that multiplication done, which is 16.2. Then take the 10 to the negative 6 times the 10 to the 4th and use my exponent rules. That's really what we were going for on this. 10 to the negative 6 Remember, when you multiply by 10 to the 4th, you add the exponents. So negative 6 plus 4, negative 6 plus 4 is negative 2. I'll erase that. Negative 2. So this could be shortcutted, and this is meant to be a shortcut to get this answer. This times this, and then multiplying the tens. Then it asks us to completely finish this in decimal notation, so move it 2 places. Remember, the negative means move it to the left, so it becomes 0.162. And again, I realize you could have just started the problem from the beginning, punched the whole thing in your calculator and got there as well, but I wanted you to see that the Exponent Rules is in the way that kind of the book was going for. Okay, number 19, another application with Exponent Rules with scientific notation. We can divide these numbers and divide these numbers separately. Since that is a times sign, we have freedom to cancel out. You can cancel out when you're multiplying. So we can reduce this part, 9.028 divided by 5.81, and that is approximately 1.5538. It kept going, but I've stopped at 4 decimals. And then dividing this, remember, when you divide exponents, subtract. Dividing with like bases, exponents subtract. So 7 minus 5 gives me 10 to the second. And then that's like saying times 100. It's a positive exponent, so it moves the decimal over towards the right, makes it bigger, you know, because we're multiplying by a positive amount. So it's 1.55. Oh, I'm sorry. So we're not going to take this one out of decimal notation. We're going to leave it in scientific notation. I just realized the directions were different here. So we're going to leave it as 1.55. If we were asked to get it in decimal, we would move it over 2 places. It would be 155.38 or whatever it said it round to. But leaving it in scientific notation, it says with 2 decimal places. So the 3, 2 decimal places, then the 3 says don't round up, so we leave that as a 5. So it stays 1.55 times 10 to the second, and that would be in scientific notation. So I think I'll cut off there into chapter 5.